All right. So let me show you how you can specify the model. How do you specify the model? Okay. This is how you do it. Okay. In order to specify the model, you got to know the content of the model. And in this case, the first content was kill. So your kill must be on the left-hand side. Then you bring your beta naught. Okay, that is an intercept. Then you bring your beta 1, and then you attach the first independent variable, which in this case was price. Then you bring your beta 2. You attach the second independent variable, which was complement price. Then you do the beta 3. You add the third variable, which was income. Then plus your beta 4. Then you add your next variable, which was location urban. Just as it is in the work, you do it. Then you add your beta 5. And then you write your occupation teaching. Okay. So this one is OCC teaching. So you write that as it is. Then you do your beta 6. I'm doing all of these things for a reason. Beta 6, then you do your occupation trading. Okay. Then add your beta 7 and do your religion Christian, just as it was written. Then plus your beta 8. Okay. And then do your religion Muslim. And then finally, don't forget to add your error term, which is your UR. Now, if this is a cross-sectional data set, it is important that you indicate I for each one of these variables. I, subscript I for each one of them. This is how you specify the regression model. This is how you specify the entire regression model. So you got to learn how to specify the model. Okay. The real specification is this. You got to write them as it is. So when in this course, when I tell you to specify a model, you got to specify the model in a format that is according to the headings that were used. Okay. Now, but how do you write the estimated equation? The estimated equation is simply replacing the betas with the actual numbers. So when you go and check the values for beta naught was there. The value for beta 1 is there. So this becomes your estimated regression equation. So the regression equation has the coefficients attached to the letters. The coefficients are the betas, which are now numbers. And you should also remember not to bring the error term, because once the model has been estimated, one of the assumptions of regression is that expected value of the error term must be what? 0. And so you don't have to bring the error term in the end. So the difference between the specified model and the estimated equation must be clearly defined. You got to be clear about how each one looks like. This is 8. This is 8. The other one is prediction. I don't want to bore you much with prediction. Okay. You can look at a prediction story, but prediction is simply when you use one of the independent, when you know the value of the, if you look at the estimated equation like this, if you know the value of the letters, you can find the K value. That is basically what prediction is all about. That is what prediction is all about. Yes, Justice.
Doc.
Yes.
Please, I want to find out something quickly. With the interpretation, especially for the categorical variable, we said the interpretation is in respect of the reference category. So for Muslim, if you want to do the interpretation for the coefficient of Muslim, it will be in reference to Buddhist. But what if I want to do an interpretation between Muslim? I want to find out whether between Muslim and Christian, the difference in their consumption or their quantity demand. How do I do that? Because in this case, Christian is not a reference category, but I want to do an interpretation, look at the consumption difference or the quantity demand difference between that of Christians and Muslims. How do I do that?
All right, so there are two ways. One way is that you can encode in R and tell R that you want him to actually use this as the reference category. Okay, that's one. The other thing is that if the relationship is very simple, let's say that you are comparing Christians with Buddhists and quantity demanded is up by 15 units if the person is a Christian than Buddhist. Okay, then you look at Muslim. Quantity demanded is up. Okay, so here it's not up. Okay, if you look at here, it's minus. So quantity demanded is predicted to be 23 units less if the person is a Muslim than a Buddhist. So when I compare a Muslim with a Buddhist, quantity demanded is less if the person is a Muslim than a Buddhist. And quantity demanded is more if the person is a Christian than Buddhist. On the basis of these two, you can use that to be able to know the relationship between a Christian and a Muslim. Apart from the software can easily turn everything around and then give it to you. Okay? So what it means is that between Christian and Muslim, if Muslims are 23 less compared to Buddhists, but Christians are 15 more compared to Buddhists, then between Muslims and Christians, you just add the 23 plus the 15. So between Christians and Muslims, you can say that Christians are 23 plus 15 more. Sorry, not more. Christians, quantity demanded is going to be, let me add a number. That is about 38, okay? So Christians, quantity demanded is going to be 38 units more if the people are Christians than they are Muslims. Does that make sense? Do you get what I'm trying to do?
Yes, please.
Yeah, so you can do that easily. Okay. Or you can let the software do that also easily for you. So there's no problem with it. All right, so ladies and gentlemen, that is how we end the cross-sectional data. We have been able to solve the thing, but there may be problems in our results. And this is called regression diagnostics. We will come back in 2 weeks to look at regression diagnostics. But until then, we are meeting next week to do some corrections.